the stuff we're learning right now, but right now it's been moved back to Monday. So I want you to have time to do the work and have questions. And if we don't, I may end up moving it back another day. I'll do what I need to do to make it work.
You should move it to Tuesday.
I very well may.
Yeah, actually,
Oh yeah. I mean, she's done all the work. She can do it.
Okay, here we go. The first one, limit as x approaches negative infinity of f of x. What'd you get, Win? That's right. As I go to the left, it's going up forever. Brooklyn, what about the next limit? -2. As I go to the right, it's approaching this horizontal asymptote, which is at -2. All right. The next one, limit as x approaches negative infinity of f of x. Faith? Yeah, as I go to the left, notice it's approaching the asymptote, which happens to be -2 again. Limit as x approaches negative infinity of f of x, Daniel?
infinity or negative?
This should have been infinity. The answer is infinity. Did I say it wrong?
Yeah.
Okay. So as I go to the right, it's going up forever. Stephen, what about the next one? Negative infinity is right. As I go to the left, it's going down. Next one, Win? -1. As I go to the right, it's approaching the asymptote, which is at -1. Brooklyn, next one? 2. Again, as I go to the left, it's approaching that asymptote. And the last one, Faith? Yes, as I go to the right, it's going down forever. Okay, so what are our possible answers here that we're getting?
Negative infinity.
Negative infinity? Infinity, I heard. -2. -1. What do those represent in these graphs? Asymptotes. The horizontal asymptotes. So those are good bits of information for limits of exponential functions. It's going to be one of 3 things. It's going to be negative infinity, infinity, or the horizontal asymptote. Now let's look at how we get those graphs, because that's what's going to determine things for us. Okay. It says remind yourself of the rules. Well, let me teach you the rules. Okay. A growth function looks like this one and this one. And their growth, because of what's going on, it's going from down to up. It's moving up. Same thing here. It starts down if I read it from left to right, and it's moving up. Those are called growth functions. To look at the equation and tell if it's a growth function, there's 2 things that can happen. One, it's a growth function if the base, which is the number that's being raised to the power, if the base is greater than 1 and there's 0 or 2 reflections. Now, reflections are the numbers, the negatives that are out in front of the entire thing or just out in front of the x's. So, let's see, this first one, the first one, 3 over 2 is your base. So that's bigger than 1. And there are no reflections because I don't have a negative out here and I don't have a negative in front of that x. That's what reflections are.
You're talking about the next one that you said was a growth function. There's not one in front of the x, there's one in front of the 2. So, the half, sorry.
Oh, on this next one, that's going to be the second part.
And it's less than.
Right. So that's one way you can get it. Another way is you get a growth if B is between 0 and 1, and there's just one reflection. Because what happens if it's between 0 and 1, that usually means it's decay. But if you flip it over, it becomes growth. So that's why one reflection is changing it back into growth. If you have two reflections, then it kind of undoes itself. So that's why on the top one, 0 or 2 reflections still means it's growth. So number 2 corresponds to this one. 1/2 is between 0 and 1, and there's one reflection, that little negative. That is also what makes it go below the asymptote.
The reflection.
Yeah, that negative in front of the 1/2.
Did they reflect over the horizontal asymptote?
They reflect actually over the x-axis, is what that is. And then the asymptote, that -1 right here, that's what moves everything down 1.
Okay.
And that's where the asymptote's coming from as well. Okay, so let's look at decay. Decay is going to be basically the opposite. Decay is if B is greater than 1 and there's one reflection. So it was growth, but then you flipped it. So, oh, you probably haven't done that in this part. I see this test being Tuesday, or the quiz being Tuesday. Sorry, Ashley. Sorry. Yeah. Let's see what else was I gonna say about that. I guess that's it. Oh, make sure you're doing the homework from this section to be starting on it, because I'm gonna post it probably today. It's day 4 homework. Okay, so decay when B is greater than 1. So that looks like this one. No, that doesn't. I'm just kidding. It may be neither one of them. Oh, it's neither one of these. Is it? No.
See, I just looked at it. I'm confused.
No, I just don't happen to have one of those on here. But that's still a decay. The next one. Oh, God. Sherry. It's decay if 0 is between B and 1 and there's 0 or 2 reflections. So decay means that it's going to be going down.
What if there's like 4 reflections?
Wouldn't that undo
Wouldn't that
itself?
be the same thing?
If there's like what?
4 reflections?
Well, you can only have 2. Yeah, you get a reflection by putting a negative in front of the whole thing, or a negative in front of the x. Those are only 2 ways you can get reflections. Good question. So like this first one, 2/3 is between 0 and 1. There are no reflections. Notice how it's going down. That's a decay. On this next one, 1/2, that's between 0 and 1, and there are 2 reflections because of this negative and that negative. It's still going down. Notice this time it's below the asymptote, and that's because of this negative. And the +2 is what gives you the asymptote. Tomorrow we'll practice on graphing our own, which is the 1 through 8. Tomorrow's Friday. Yeah, okay.